So in this lesson, we're going to be looking at quadratic functions from 3 points. So it says a minimum of 3 points that lie on the graph of a quadratic function are required to formulate its equation. So solving a 3 by 3 system of linear equations is one approach to writing a quadratic function given 3 points from its graph. Okay, use the general standard form of a quadratic function and the 3 given points to formulate the system. So you're going to come up with 3 equations. You're going to solve the system using any appropriate method. So the examples or the ways that we have gone over is substitution, elimination, inverse matrices, and augmented matrices, which is our reduced row echelon form. Okay? All right, so first thing we want to do on example 1, we're given 3 points. We know the first coordinate is x, then y. So what I'm going to do here is I'm going to plug this into my general standard form equation for a quadratic. So I'm going to plug it in, my x and y, and then I'm going to end up with 3 different equations. So I'm going to start with the first one. So that would be the y is -4. The x is -3. So I'm going to have -4. When I square -3, I get 9. So that's 9a minus 3b plus c. So there's 1. Now I need to do the same thing, but I will use the second point. So I'm going to plug in. So that's going to be 6 equals a times x, which is 2 squared, plus b times 2 plus c. So that's 6 equals 2 squared is 4, so 4a plus 2b plus c. So there's my second equation. And then my third equation, plugging in that last point, would be 24 equals a, x is 4. So that's 24 equals 4 squared is 16, and then a, 4b plus c. All right, so there's my 3 equations. So we're going to solve this system. You can use whatever method you want that we've gone over, which we just talked about up at the top. So I'm just going to use augmented matrices. So I'm going to set up my 3 equations. So I'm going to go ahead and write my 3 equations again, but I'm going to put my constant on the right side. It's the same thing. Just so I have it all together here. So again, you can use substitution, elimination, inverse matrices, or augmented. So I'm just going to use augmented. So I'm going to set up my one matrix. So 9, -3, 1, -4. 4, 2, 1, 6, 16, 4, 1, 24. And then I'm going to type those into the calculator. So if you don't remember what to do for that, you're going to second matrix. I'm going to edit, I'll just edit A. It's a 3 by 4. So typing it in, I would have 9, -3, 1, -4, 4, 2, 1, 6, 16, 4, 1, 24. Okay, so once we've typed it in, remember, go back to your home screen, so second quit, and then you're doing second matrix, go to math, and then you're going to go to your reduced row echelon form, and we plugged it, or I plugged mine into matrix A. So I'm going to do second matrix name A. And then it gives me my solution here. So writing that down. Remember, the last column would be your solution. So A would equal 1, B would equal 3, and C would equal -4. Okay, so once we find A, B, and C, then we can plug it back into the standard equation to find our actual quadratic equation. So y equals A is 1. So I actually don't have to write a 1. I can just put x squared. Plus B is 3, so 3x. And then plus C is -4, so -4. So we're looking for our quadratic function given 3 points. So we can set up our 3 equations, and we can solve it whatever way we want. Once we find our A, B, C, we can plug it back in, and then we can find our quadratic function. Okay, if it wanted it in function notation, you could just write this. So those mean the same thing. All right, let's look at example 2. So we're going to use the systems approach to write a quadratic function to represent the function graphed below. So first thing I want to do is I'm going to find these 3 points that were they already dotted for us. So the 3 points are 0, -3, 2, -5, and 3, 0. So we're plugging in. So we would have A and then 0 squared plus B times 0 minus C. Sorry, go back. So that would be plus C equals your Y, which is -3. So 0 squared 0. A times 0 is 0, B times 0 is 0, so all I have for that one is a C equals -3. So looking at my next point, I would have A times 2 squared plus B times 2 plus C equals -5. So that would be 4A plus 2B plus C equals -5. And then for my third equation, I would have A times 3 squared plus B times 3 plus C equals 0. So that would be 9A plus 3B plus C equals 0. So now here are my 3 equations right here. So I'm going to set up my matrix. You can use it whatever method you want. So my first column are my coefficients of my A. So I would have a 0, 4, 9. My B would be 0, 2, 3. My C would be 1, 1, 1. And then my constants, -3, -5, and 0. So setting up your matrix, when you plug it in, make sure you do second matrix math and then the reduced row echelon form. You should get A equals 2, B equals -5, and C equals -3. So plugging in, you would have Y equals A is 2, so 2x squared, plus B, B is -5, so minus 5x, and then plus your C, so minus 3. Again, function notation, they mean the same thing, okay? So you can write either or. All right, so you can choose whatever method you want. I just use reduced row echelon form. So I plugged in my matrix, and then I found my solution. Okay, let's take a look at the back. So regression approach, so this is a different approach. So that one I used 3 points, and then I plugged them in order to solve my solution. So this one is going to be quadratic regression, performed using your graphing calculator or other technology offered. So We're going to be given 3 or more points, and then we're going to use that data in order to find our solution. So first thing I want to do, I'm going to go ahead and write down my calculator instructions for our calculator that we use in class or the one on the iPad. So first step is to go to Stat, Edit. So Stat over to Edit, and then you're going to enter your data, which is this. And then your second step is to go back to Stat, go over to Calc, and you're going to go to number 5, which is the quadratic regression. And then the third step is to substitute in for your A, B, and C into your standard form. Okay, so let's go to our calculator. So you're going to go to Stat, which is right below the Delete button. You're going to go to Edit, which it's already on Edit, so press Enter. Now, yours probably looks a little different if you're not using the iPad one, so you're always going to put your X values in L1. So our X values on this are negative 32 and then negative 10. Nope. And then our next one's 18. And then go over to your list 2, type in your Y values, negative 49, press Enter, negative 126, press Enter, and then negative 574. Okay, so once you've typed it in, make sure you double check those numbers. We have them typed in correctly, so we go back to the home screen. And then we're going to go to Stat, which is Delete, right below Delete, Stat. Go over to Calc, and you're choosing quadratic regression, which is number 5. And just press Enter. And then on my calculators in class, you'll just go down to Calculate. So notice it gives you your A, B, and C. So we're going to transfer that. So notice we have the A, B, and C here. So we're going to plug that into our quadratic. So we should get Y equals negative 0.25x squared minus 14x minus 241. We found A, B, and C. And then the same thing, you can write it in function notation form. So there's your quadratic. So this is another way of finding your quadratic function. If you're given 3 points, you can plug it in the calculator, go to Stat, Calc, number 5, quadratic, and then substitute your A, B, and C in. All right, let's look at the last one. So a frog's path while jumping can be modeled by the quadratic function. So here's our parabola. Notice use quadratic regression to write a model representing the vertical distance y in feet traveled by the frog, where x represents the horizontal distance traveled in feet. Okay, so we're going to select at least 3 points from the graph. It doesn't matter what 3 you're going to do. So I'll do 3, 1. I'll do 6, 1. And I'll do 9, 0. So I'm going to use those 3 points to plug in like we just did on quadratic regression. So I'm going to go back to Stat, which is below Delete. I'm going to go to Edit. So I'm going to type in 3, 6, 9, and then go 1, 1, and 0 for my Y values. So remember, X's go in the first column, your Y's go in the second. Go back to Stat, go over to Calc, and then quadratic is 5. Press Enter. Hang on, sorry, I messed up. Number 5. All right, so we're going to write down our A, B, and C. Notice our C is 0, which means it would cross the y-axis at 0, and also meaning Your C you don't have to write, so we're going to plug in for A, B, and then that will give us our equation. So we'll have f of x, or y equals, I'm going to round it to 2 decimal places, so 0.05 x squared plus 0.5x. Remember our C was 0. It says identify the vertex using the equation found in part B. Remember the vertex when you're in standard form to find the x is negative b over 2a. So if I type that in, that's negative 0.5 over 2 times negative 0.05. So let's go ahead and type that in. So that would be negative 0.5 divided by, open your parentheses since you're dividing by more than one thing. So I need to do negative 0.05 times 2 because it's 2a. Notice we get 5 for x value. So there's the x value of the vertex. Once I know x, I can plug it into my 2 x's here. Lots of 5s going on. So let's type it in the calculator. So that would be negative 0.05 and then, sorry, let me clear it. So that would be negative 0.05, open parentheses, times it by 5, and then square it, plus 0.5 times 5. I do not like this calculator. Okay. So we get 1.25 for the y value of the vertex. So remember, to find x, we plug it into this formula when it's in standard form. To find y, we just replace all of our x's on our equation to find the y value of the vertex. Notice you can also look at your graph. You're trying to find where your vertex is, where it says approximately around 5 because of that negative 0.05 repeating. So somewhere in this area here would be your vertex. State the domain and range of the situation. So it's been a while since we talked about those two. Domain is all of the x values. So notice this is our x value, or x-axis. We're going from 0 all the way to 9. So 0 to 9, it includes both, or you can use inequalities. And then our range is going from 0, because it's at 0 right here, and then it goes all the way up to that maximum. So that maximum would be 1.25. It's also a bracket. Okay, this is how we can find quadratic functions given 3 points. So we can either write our system of equations, solve it whatever way we want, or we can plug it into the calculator and use quadratic regression. Let me know if you have any questions.